I'm Mingbei Liu from Beijing 101 Middle School, and today my topic is determining the absorption mechanism between surfactants and solid particles. So here's my agenda for today. I'm gonna first talk about my background information about the research and also the research question and objectives, and of course the significance of the research. And also I'm gonna talk about some procedures of my experiment. And lastly, I'm gonna talk about some safety, ethical, and environmental issues. So about the background information, there are two concepts that should be in mind, which are adsorption and desorption. So basically, you can see on the left side of the diagram that adsorption refers to the blue dots attached to the solid, whereas desorption is basically the opposite of adsorption, which the solid particle releases those blue dots. If we go deeper into the adsorption, we can have two categories, which are monolayer adsorption and multilayer adsorption. As for monolayer adsorption, we can only have one layer of surfactant on the solid surface, whereas for multilayer adsorption, we can have many layers of surfactants on the solid surface. So if we're going to graph it, so if we continuously increase the initial concentration of the surfactant for monolayer adsorption, the amount of surfactant being adsorbed will eventually reach a plateau, which on the graph you can see the slope will eventually approach zero. However, as for multilayer adsorption, the slope will never approach zero. As you continuously add or increase the initial concentration of the surfactant, you can see that the amount of surfactant being absorbed will continuously increase. And so my research can have many applications. For instance, sewage treatment in soil. We can actually use that black thing on the left side of the screen to pave the soil and to absorb the pollutants in soil so that the soil can be cleaner than before. And secondly, we can apply physical absorption into the air purification. We can purify the air by absorbing the pollutants in the air. So about my own research and objective. So my question is, what is the absorption mechanism between each pair of surfactant and solid particle? I've listed the surfactants on the left side and the solid particle on the right side. So as for the objectives, I'm going to determine the mechanisms between the solid particle and the surfactant about their absorption. Significance of the research is that I can actually suggest the appropriate amount of catalyst added in an industrial production, because the production is usually performed in a great scale. So if we only add a little bit of that catalyst, the reaction rate will not be promoted that much. However, if we add too much catalyst, the additional increase of the reaction rate is not worthy for the amount of catalyst being added. And also, my research can help to improve the water conditions, since we can use physical absorption to absorb some pollutants in water. And my intended audience are people who engage in physical absorption or catalyzation. So during my research, I've prepared systems of surfactants and solid particles as you can see on the left side of the screen. I've prepared so many bottles with surfactant solutions and solid particles inside. And on the right side, I was determining the surfactant concentrations at equilibriums by using aberrefractometer. So I'm going to use the refractive index to reflect the equilibrium concentration of the surfactants. So in order to do this, I'm going to have a working curve. So it is necessary for me to set up the working curve first, and later on, when I'm trying different concentrations of the surfactants, I can basically refer to the working curve to make my work easier. And also, I can vary the mass and the type of the solid particles. So actually, my research did not achieve my objectives yet, but still, due to the limiting access to aberrefractometer and the limited time. However, I still have some findings. For instance, Coulomb's force plays the dominant role in absorption, which I mean the surfactants and solid particles with different surface charges perform better absorption than the combinations with the same surfactant charge. So as for the safety and ethical and environmental issues, so I want to clarify that my research or my experiment has no chemical change occurred since it is only about physical absorption. But still, powders may get into our lung, which means that we're going to wear masks during the experiment. And also, the surfactants are less polluting, so it's not a big deal for the environment. It is environmental friendly, I mean. And basically, that is all for my presentation, and thanks for watching.